Hey guys, today is March the 7th and I'm going to do another LeetCode Daily Challenge. So let's get started. Okay, minimum recolors to get k consecutive black blocks. You are given 0 index string blocks of length n, where block I is either W or B, representing the color of the ith block. The characters W and B denote the colors white and black respectively. We're also given an integer k, which is the desired number of consecutive black boxes. In one operation, you can recolor a white block such that it becomes a black box. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So first of all, just reading this feels like some sort of like sliding window type of problem, where our window is k. So we'll see, yeah. So if we're on here and it's W, why don't we change it to black? Now that we have 2, we have 3, we'll change that to black as well. So we have 4, 5, 6, 7, with 3 operations. So then we will start actually sliding our window. Okay, so I think that's what I'm going to do. Maybe I could explain that a little bit better. So if we have white, black, black, white, white, black, black. Right, wait, sorry. White, black, black, white, white, black, black, white, black, white. White, white, black, white. And then we will do some sort of sliding window, which means we're going to have like a left and right pointer. And originally the left and right pointer is going to be at the same spot. And then afterwards, right is going to keep going. Or we process the right pointer and we see that it's white. So let's change it to black. So maybe I could keep track of how many operations I've used so far. So how many operations in this window is 1, right? Because we're flipping this white to black. So we're literally going to flip it to a black like that. So that's what it looks like. That's why our operations go up by 1. Then right goes over here. If it's black, we don't do anything. We just go here. Black, don't do anything. White, let's change our operation a bit. So now this is going to become 2. And then we could keep moving on. We haven't, our window, we know when we will start shifting left when our window size is 7, or if it's size k. But right now it's not k, right? So we just keep going. It's white, so we're going to change this to a 3. And then we just keep shifting here, 1, 2, 3, 4, 5, 6, 7. So now it's 7. Then we can now go, okay, here's right, and then here's left. Okay, so I think that we'll just use some sort of sliding window to help solve this problem. Yeah, sliding window should be fine. So I'm going to be operation, ops is 0, and we want the minimum ops, right? So actually, so the current ops is 0, the min ops is going to be something super big for now. Left is 0, for right in range, the length of the blocks. So now we have to process right. So the current color is at blocks at right. If blocks at right is a white one, then we want to recolor it, right? So we want to recolor it, which means the operation needs to go up one. Okay, now we need to check if the window is length k. If it's not, we just continue. So if that means if right is less than k minus 1. I always get confused on this, so let me see. 0, 1, 2, wait, 1, 2, 3, 4, 5, 6, 7, which means 0, 1, 2, 3, 4, 5, 6. So if it's less than 6, which is k minus 1. Yeah, if it's less than 6, then we just continue. Okay, otherwise, see if the current window has the min ops. So we just say min ops is the min of itself, min ops or cur ops. And this should actually be cur ops right there. And then after that, we need to start shifting the left pointer over, which means we first need to remove it from the window, right? So we check if blocks at left is W, then the cur ops minus equal to 1 because we're now getting rid of it from the window. And then no matter what, left is going to go up 1. Okay, that should be fine. And then we just need to return the minimum operations, and that should be it. Okay, I'm submitting. Awesome. So yeah, I mean, I see why it's an easy problem, but first of all, I didn't explain it super well, but I'm not going to get into this. But the whole idea of sliding window, I think, is kind of tough when you first see it, but it's one of those things you just need to like sit down and like draw it out, because all of these things that I commented, these are all just like, you'll see this in every sliding window problem. So I get why it's easy, but I don't think it's super easy to just come up with this on your own, right? You have to have studied it or seen it first. But anyways, yeah, nice little problem today, and see you guys tomorrow.